There's a phrase that Tim Berners-Lee, the inventor of the World Wide Web, wrote in 1998 in a document about web architecture. The phrase was, "Cool URIs don't change." It's a deceptively simple statement, almost a throwaway line, but it encapsulates something that engineers, system designers, and anyone who has ever managed a large web property learns the hard way. The moment you publish a name, a URL, a domain, an API endpoint, a service identifier, that name begins accumulating weight. People link to it. Systems depend on it. It gets embedded in documents, in code bases, in emails, in databases, in other people's infrastructure. And with every passing day, every additional reference, the cost of changing that name grows. By the time you feel the need to change it, the damage a change will cause is often far larger than anyone anticipated. This is what name stability means. Not that names never change, they do, and sometimes they must. But that stability is a property worth designing for deliberately, before you make naming decisions you'll later have to live with. Let's build up to this carefully, because stability is one of those concepts that's easy to state, but surprisingly rich once you start pulling on it. When we say a name is stable, we mean that it reliably resolves to the same resource over time. You use the name today, you use it next year. The same name, the same resource. The connection is persistent and dependable. When we say a name is unstable, we mean that this reliability breaks down. The name changes and now refers to something different, or the name stops resolving at all, or the same name resolves to different things, depending on when you ask, or it resolves to the right thing most of the time, but occasionally fails. Now, notice something important. Stability is about the relationship between the name and the resource, not about either one in isolation. A resource can move, its address can change, its servers can shift, its infrastructure can be overhauled entirely, and the name can remain perfectly stable as long as the name continues to resolve to that resource. We talked about exactly this in the aliasing video. Part of the reason CNAME chains and DNS abstraction are valuable is precisely that they allow the underlying infrastructure to change while the name remains stable. Conversely, even if the resource itself never changes, sits on the same machine, at the same address, doing exactly what it always did, the name becomes unstable the moment someone changes the DNS records, or takes down the name server, or lets the domain registration lapse. Stability is a property of the mapping, and it can be broken from either end. To understand why stability matters so much, you have to understand how names accumulate dependencies over time. This is the mechanism that makes renaming expensive, and it's worth tracing carefully. The moment you publish a name, you're making an implicit promise to anyone who uses it. This name will work tomorrow, and the day after, and next year. You probably haven't thought of it as a promise. You're just putting a URL on a web page or an API endpoint in documentation. But from the user's or system's perspective, that name is now a dependency. They're relying on it. Think about the different kinds of dependencies a name can accumulate. There are human references, the most obvious kind. Someone reads your blog post, copies the URL, pastes it into an email, a Slack message, a document. That URL now exists in dozens of contexts you'll never know about. Someone bookmarks your page, someone tweets your URL. With every passing day, more people have recorded your name in more places. You have no inventory of where those references are. You have no way to update them. They're out there, and they're permanent. There are machine references, arguably more dangerous because they're invisible and often critical. Other systems' code has hard-coded your API endpoint. A monitoring system is pinging your URL to check if it's up. A data pipeline is fetching from your endpoint every hour. A mobile app whose users haven't updated in 3 years is calling your service. A third-party integration is pulling your RSS feed. None of these systems will update themselves when your name changes. They'll just start failing, silently or noisily, and tracking down every one of them is detective work. There are SEO dependencies, a more modern form, but an increasingly consequential one. Search engines have indexed your URLs. Other websites have linked to them. And those links, over years, have accumulated what's called link equity in SEO language. The ranking authority that search engines assign to a page is tied partly to the specific URL, Change the URL and you potentially lose years of accumulated ranking. The name, in this context, is not just an identifier, it's an asset. There are cached references, copies of your name and what it resolves to that exist in DNS caches, in browser caches, in CDN caches, in application caches all over the world. When you change a name, those caches still hold the old information. Depending on how aggressively the old records were cached, and for how long, there's a window, potentially a long one, during which different systems are operating on different beliefs about what your name means. And there are trust dependencies, perhaps the most subtle. Users and systems that have interacted with your name have built up trust in it. They recognize it. They've verified it before. Security certificates are issued for it. TLS handshakes succeed because the certificate matches the name. Change the name, and all of that trust history is irrelevant. You're starting from scratch. Every day, a name exists in the world. It accumulates more of all these dependencies. The name becomes more embedded, more referenced, more relied upon. The cost of change compounds continuously, like interest on a debt. And crucially, much of this accumulation is invisible to you. You can see your own codebase, your own documentation. You cannot see every place someone has hard-coded your URL. Now let's make this concrete by looking at what actually happens when a name changes, across a few different scenarios. Scenario 1, a URL changes. A news organization has been publishing articles at URLs like news.example.com/articles.papt for 10 years. They redesign their website. The new system uses a different URL structure, news.example.com/story/ every single old article URL, millions of them, no longer works. Anyone who bookmarked an article, linked to it, shared it, cited it in an academic paper, they all get a 404 error. The content might still exist on the server, but the name used to access it is gone. This is link rot, one of the chronic, slow-moving pathologies of the web. Studies have estimated that a significant fraction of all URLs that have ever existed no longer work. Some estimates put it at over 50% for URLs that are more than a decade old. Every one of those broken URLs represents a name that changed, a mapping that was severed. The web was designed around the assumption that URLs are persistent. When they aren't, the hypertext fabric of the web, the links that connect documents to each other, silently decays. Scenario 2. An API endpoint changes. A software company has a public API. Developers around the world have built applications that call api.example.com/v1/data. The company releases version 2 of their API with a redesigned structure. The old endpoint stops working. Every application built on the old API breaks, not gradually, immediately. Every developer who used api.example.com/v1/data now has a broken product to fix. Good API design tries to avoid this by versioning, keeping old endpoints alive while adding new ones, so developers can migrate on their own schedule. But this is expensive to maintain indefinitely, and eventually old versions get deprecated and shut down. The name change is just delayed, not avoided. Scenario 3. A domain name changes. A company rebrands, oldname.com becomes newname.com. The old domain is either abandoned, let lapse, or redirected. Every link on the internet pointing to oldname.com, in articles, blog posts, social media, other companies' integrations, now either hits a redirect or hits nothing. Every email address stops receiving mail unless carefully forwarded. Every security certificate issued for oldname.com is suddenly for a domain that the company no longer primarily uses. Rebrands are expensive not just because of marketing materials and signage, but because of the deep infrastructure cost of the domain name change underneath. Large organizations sometimes maintain old domains for years, paying the registration fees, maintaining the redirects, purely because the cost of completely abandoning the old name exceeds the cost of keeping it alive in a minimal form. So how do systems try to handle name changes gracefully? Because names do change, and sometimes they must. The question is how to manage the transition so that the dependency breakage is minimized. The most widely used mitigation on the web is the HTTP redirect. When you change a URL, instead of simply removing the old one, You configure your server to respond to requests for the old URL with a special response that says, "This resource has moved. Here's the new name." The browser automatically follows the redirect and loads the new URL. The user barely notices. There are two main kinds of redirects, and the distinction matters more than most people realize. A 301 redirect is a permanent redirect. It tells the browser, and critically, tells search engines and other automated systems, this resource has moved permanently to the new URL, and you should update any references you have. A browser that receives a 301 will typically remember the redirect and skip asking for the old URL next time. A search engine will transfer its index entry from the old URL to the new one, carrying along the accumulated link equity. A 301 is the right choice when the move is final and you're confident it won't change again. A 302 redirect is a temporary redirect. It says, this resource is temporarily at a different URL, but keep using the old one going forward. Browsers don't cache 302s the same way. Search engines don't transfer link equity. Use a 302 when you're doing maintenance, running an A/B test, or genuinely not sure if the move is permanent. Using 301 redirects correctly is the closest thing the web has to a graceful name change. You maintain the old name, accept requests for it, and silently forward them to the new name. Over time, hopefully, people update their bookmarks and links. Eventually, you can turn off the redirect. But notice what maintaining a redirect requires. You have to keep the old name alive. You can't truly delete it. You have to keep the DNS record for the old domain pointing somewhere. You have to keep the server configured to handle requests for the old URL. For domain name changes, this means paying registration fees for a domain you don't really use anymore, potentially indefinitely. For URL structure changes, this means maintaining redirect rules in your server configuration that accumulate over years and eventually become a tangled legacy nobody wants to touch. Redirects don't eliminate the cost of name change. They distribute it over time and shift it from users to operators. The users stop noticing the breakage fairly quickly. The operators are paying the maintenance tax quietly for years afterward. There's a related problem that's worth naming explicitly, the deprecation problem. When you change a name, you face a decision about how long to maintain backward compatibility, how long to keep the old name working alongside the new one. Keep it too long, and you're maintaining dead weight, confusing newcomers who encounter the old name and creating an implicit signal that changing names is painless because you always keep the old ones alive. Let it go too soon, and you break systems that haven't had time to migrate. There's no universally right answer. Different systems make different trade-offs. Good API versioning strategies often commit to keeping old versions alive for a defined period, 1 year, 2 years, with clear deprecation notices and migration guides published well in advance. The old name stays fully operational during the deprecation window. After the window closes, it's gone. This gives dependent systems a known bounded time to migrate, while putting a firm end date on the maintenance burden. Web URLs are less disciplined about this. Many organizations intend to maintain redirects for a while, but never formally commit to a deprecation timeline. The redirect stays alive until someone finally questions why it's there, at which point nobody wants to be responsible for removing it in case something breaks. The result is redirect configurations that accumulate over decades, growing increasingly hard to understand, maintained by people who weren't there when the original name change happened. The lesson here is that deprecation should be treated as part of the name change plan from the beginning, not an afterthought. When will the old name stop working? Who is responsible for communicating that to dependent systems? How will you notify people? What happens to systems that don't migrate in time? These are questions that need answers before you flip the switch, not after. Let's talk about something that often gets overlooked in technical discussions of naming: the organizational and political dimensions of name changes. Names aren't just technical identifiers. They carry meaning, identity, and often history. Inside an organization, the name of a system, a team, a product, or a service is often tied up with how people understand their work and their relationship to it. When a company acquires another and starts migrating services under the new brand, the name changes carry emotional weight. People who built something under the old name experience the renaming as erasure. Teams resist changing the names of their services because the names are how they identify what they built and what they're responsible for. Conversely, names can carry negative associations. A product that failed, a service that had an outage, a brand that became associated with controversy. Sometimes the name itself becomes a liability, and changing it is motivated by the desire to break association with a history. The technical cost of the name change is knowingly accepted in exchange for the reputational benefit of a fresh start. Domain name changes happen constantly in the world of corporate mergers and acquisitions. When a large company buys a smaller one, there's usually a period where the acquired product operates under both names simultaneously, NewCo, formerly OldCo. The technical systems are running redirects, maintaining both domains, carefully managing the transition. The legal and marketing teams are coordinating the timing. The engineering teams are updating code bases. The SEO team is watching traffic numbers anxiously. All of this happens because the name accumulated the weight we described. The brand existed in the world, in people's memories, in links, in integrations. Moving the brand requires moving all of that accumulated weight, carefully, over time, hoping nothing tears under the strain. And sometimes, things do tear. Migrations go wrong. Redirects get misconfigured. Old domains get abandoned before all traffic has fully migrated. Search rankings collapse because 301s were implemented as 302s by mistake. Email routing breaks because MX records weren't updated in the right order. Name changes are, in practice, some of the riskiest operational events that organizations go through. Not because any single step is difficult, but because the surface area of potential breakage is so large, spread across systems, organizations, and time, that it's genuinely hard to predict and test in advance. So what does all of this tell us about how to approach naming from the beginning? The first principle is treat names as long-term commitments, not temporary identifiers. When you name a public API endpoint, a public URL, a service that other systems will depend on, you're making a commitment to that name. Treat it with the seriousness of a contract. Think about whether the name will still make sense in 5 years. Think about whether the organizational structure it reflects is stable or likely to change. Names like api.company.com/v1, teams, marketing, reports encode organizational hierarchy that reorganizations will shatter. Names like api.company.com/reports encode function, which changes far more slowly. The second principle is separate stable names from unstable ones deliberately. Some names are meant to be public, permanent, and stable. Others are internal, temporary, and subject to change. These should be different names, structured differently, documented differently, and treated differently. Don't let internal names leak into external dependencies. Don't build public-facing infrastructure on names you haven't committed to stabilizing. The third principle is use indirection to decouple what users see from what the infrastructure is. This loops back to aliasing, maintaining a stable, human-facing name that resolves through a layer you control into infrastructure that can change freely. The stable name is your commitment to users. The infrastructure behind it is your implementation detail. Keep them separate, and you can honor the commitment while still evolving the implementation. The fourth principle is plan for deprecation before you deprecate. When the day comes that a name must change, have a strategy. Define the deprecation window. Communicate it clearly. Monitor which systems are still using the old name. Give dependent systems every tool they need to migrate. And then, when the window closes, actually close it, rather than letting the zombie name persist indefinitely. And the fifth principle, the one that ties all the others together, understand that the cost of a name change is proportional to how long the name has existed and how widely it's been used. A name you change 1 week after publishing it costs almost nothing. A name you change 10 years after publishing it might cost enormously. The compounding is real. The longer you wait, the more embedded the name becomes, and the higher the price of moving. Now, there are situations where instability is perfectly acceptable, where the expected lifetime of a name is short and nobody builds deep dependencies on it. Development environments, internal test systems, feature branches, temporary campaign landing pages, ephemeral cloud resources that spin up and down in minutes. In these contexts, the whole architecture of names is different. Names are generated procedurally. They're not memorable, not shareable, not meant to persist. The expectation is that they will disappear, and systems that use them know this. There are no soft promises embedded in the name, no accumulation of external dependencies. This is entirely appropriate. Not every name carries the weight of a long-term commitment. The key is being deliberate about which kind of name you're creating, and not accidentally building a production dependency on a name that was never designed to be stable. The mistake that causes real pain is when something starts as temporary and becomes permanent without anyone consciously deciding to make that transition. The development server that became the production server, the temporary subdomain that ended up in 10,000 links, the V1 API that was supposed to be replaced in 6 months and is still running 7 years later because every effort to deprecate it revealed another system still depending on it. Temporary names that become permanent are a special kind of technical debt, the kind where the bill arrives all at once when you finally try to change them, and the total is far larger than anyone expected. That's all for name stability and name changes. See you in next one.